Hello, this is Dr. Johnson. I'm one of the AP Stats teachers at Capel High School. Welcome to today's presentation on quantitative data, displaying it with graphs. First thing I want you to know is a frequency distribution. A frequency distribution tells us what values the variable takes and how often it takes each of these values. We need to know this term because oftentimes when graphing, we are going to be plotting data from a frequency distribution. Dot plots, that's the first one I'm going to talk about. Here's how you construct it. You can come back to this slide later and read it in detail, but I just wanted to get to this one and show it to you. So suppose that I did a study of matches and I wanted to count the number of matches per box, and I had several different match boxes. This is the graph that I might come up with. The vertical column is the number of boxes or frequency. On the horizontal axis, I have the number of match boxes. Each of these dots represents one match box. So you can see that there were two match boxes out of all of my match boxes that had 47 matches in them. Usually each dot represents a value of 1. This is a dot plot. Be sure to label both of your axes. And there we go. Stem and leaf plots. This is a description of stem and leaf plots. This is how to make them. You can come back to these slides later and read these in detail. This is what they look like. Suppose that I have a bunch of students. I give them a test. Their data looks like this, 49, 54, 59. Here's how I make a stem and leaf plot. So I look at it, I see I have one number in the 40s, two numbers in the 50s, a couple in the 60s. At the top end, I have two 100s. So I decide that I want to have as my stem 4, 5, 6 down to 10. So I end up with I have those stems. My leaves, for leaves, that represents the next digit in the marks. So in my stem, where I have a stem of 4, I have a leaf of 9. That represents the number 49. The number 61 is shown there. The 6 in 61 is represented by the stem with a of 6, and the 1 represents the 1 in the leaf. Now my stem and leaf plot has all my numbers in order, which makes it a little bit easy to analyze, but it's not necessary that you have your leaves in order. If you tilt your head a little bit to the right, you can see that, yeah, that kind of looks like a distribution of scores on a test. That is a stem and leaf plot. One thing you have to know about stem and leaf plots, you always have to have a key. That's the one thing students seem to forget. You must have a key. It's a bit obscured by in the bottom left-hand corner, but my key is 6 bar 1 refers to a score of 61. That's the numbers highlighted in red in my stem and leaf plot. Now, suppose that the Census Bureau projects the median age in 2030 for the 50 states like this. Well, I have 50 states, so I have 50 observations, but they all fall in the 20s, 30s, or 40s, and mostly in the 30s or 40s. So I have very few stems, and I have a lot of leaves in the 30s and the 40s. So I don't really get a good perspective of what that distribution looks like. We cannot see a distinctive shape in this distribution due to the long list of leaves. And in fact, stem and leaf plots don't work very well when you have very long leaves. But what I can do here is I can break down the 20s into 20 high and 20 low, and the 30s into 30 high and 30 low, and the 40s into 40 high and 40 low, and I end up with a graph that looks like this. In this graph, I use L for the lower leaf values, 0 through 4, and H for the higher leaf values, 5 through 9. But not all authors do that. They might just have 2, 9, 3 with 0, 2, 3, 4, and the next would be 3. They would do it without the H's and L's. But this now, because I've now divided the lower and higher leaf values, I now have a graph that shows better what that distribution looks like. So that's one way of handling that problem. You'll often see a back-to-back stem and leaf plot. And this is one way of easily comparing two distributions. So I look and at this back-to-back stem leaf plot of scores under the old curriculum and scores under the new curriculum. And to me, it looks like under the old curriculum, the scores were a little bit lower on average than those under the new curriculum. The lowest under the old curriculum was a score of 39, whereas under the new curriculum, the lowest was a 43. So it makes it pretty easy to compare two distributions, the back-to-back stem and leaf plot. As usual, you have to have a key. Always, always, always have a key. This key says 9 bar 4 bar 3. That refers to 49 under the old curriculum and 43 under the new curriculum. Always, always include a stem and leaf key. Histograms. In this page here, I describe a histogram in some detail. You're welcome to come back to this page and read it over. This is what they look like. Oftentimes we make histograms based on a frequency distribution table. On the left there, I have a frequency distribution table, and on the right, I have the histogram. My data scores run from a low of 49 to a high of 100. The frequency distribution is in the second column. The cumulative frequency distribution is in the third column, and basically that's a running total of the frequency distribution. And the relative frequency is just, since I have 37 total scores, the relative frequency is going to be calculated. Well, in the first row, I have 1 divided by 37 is 2.7. In the second row, I have 2 divided by 37, that's 5.4. In the third, I have 8 divided by 37, that's 21.6%. And from my frequency distribution, I have created a frequency a histogram. That's a histogram. I've got my bins labeled. I have frequency in the vertical axis. I've got my axis label of student scores on the horizontal axis. There you go. Now, suppose we use a relative frequency instead of frequency. So the histogram on the left shows the data in frequencies or counts. The histogram on the right shows the data in terms of relative frequencies or percents. What do you notice about the shapes of these two histograms? Well, of course, they are the exact same shape, regardless of whether you have frequency or relative frequency on your graph. My right graph, I should have included relative frequency on my vertical axis and student scores on the horizontal axis. Histograms do have shape, and we can describe those shapes. The histogram on the left is skewed to the left because it has a broad left tail. The histogram on the right is skewed to the right because it has a broad right tail. Histograms also could have these kind of shapes. The histogram on the left, we say is symmetric and bell-shaped or mound-shaped. Do not say that the histogram on the left is normal shape. Do not say it is normal shape. Normal is a distribution. It is not a shape. Now, some people might say that it is approximately normal distribution, but I think the better practice is to call it bell-shaped or mound-shaped. The distribution on the right, that's a rectangular shape. A rectangular shape. When talking about histograms, you can also talk about peaks. The histogram on the left is unimodal. The histogram on the right is bimodal. I haven't seen this on the AP exam, but that doesn't mean they can't include it. These are back-to-back histograms, making it pretty easy to compare distributions across male and female and from country to country. Ogive charts. These are also called cumulative relative frequency charts. Ogive charts. So I have an ogive chart on the right here. It shows the cumulative relative total at any given time or level. A steep slope in the ogive chart corresponds to a region in the histogram with relatively high frequencies. So in my graph on the right, my ogive graph, I notice that it is very steep, around between 40 and 50. Well, why is that? I look over at my histogram and I say, oh, it's because I have so many observations in the 40 to 50 category. On my ogive graph, I have a flat spot between 70 and 80. Why is that? Well, I go over to my frequency histogram and I say, well, there's no observations between 70 and 80 on my histogram. Flat spots on the ogive chart correspond with places in the histogram where there are no observations. Now, with these ogive charts or cumulative relative frequency charts, we love to ask questions about these. So we might ask you, at what percentile is an outcome of 35? Okay, and you're going to have to look at 35 on the horizontal axis, go up to the graph, and figure out what percentile that is. Or we might say, what outcome corresponds with the 80th percentile? So then you go up to 80% on the graph on the left, and you go across horizontally and find where the graph is, and you go down. I want to distinguish bar graphs from histograms. Bar graphs have gaps between the categories, and also the columns represent categories. We never talk about the shape of bar graphs because we could arbitrarily change the order of the columns. Bar graphs have gaps between them. Histograms have no gaps between them unless a particular bin or category has no observations. Okay? When describing a distribution of quantitative data, it is appropriate to cuss and BS. I'm going to just introduce this idea now. We'll come back to it later. That means when we ask you to describe a distribution like the ones I've just showed you, I want you to talk about the center of the distribution, whether there are unusual features, the shape, and the spread. That is the end of today's presentation. Thank you very much.